Hello everyone, I hope you all are doing well. So in this video we will go over unit 3, not unit 3, sorry, this is unit 4, my bad. Unit 4, we will go over unit 4, which is about users and permissions. So we will learn more about the users that are on Linux or Unix system. How are they added? How can you remove them? Things like that. And special files that are related to the users and permissions. And we'll also look into the different types of Unix files and the permission you can have on them. And yeah, that will be about for this unit. So the first thing, which is the most important thing, um, and I think it's even a question in exam, is to remember that Unix is basically a multi-user OS. That means multiple users can be there on the system, on the operating system, just like all of your accounts are there and all of you can use the same server. So that's the basic idea. Multiple users can have, multiple users can be using this operating system at the same time. And that happens for Unix. For Windows, I think Windows 7 is a single user operating system. Single user operating system. So basically, one user can use this operating system at a time. That's why if you need to have multiple users using this operating system, they need to buy these separate licenses. Okay, so that's the important part. Now, what is a user? A user is nothing but an account on a system that a particular individual can use. Okay, that is the definition. So I would say a user is nothing but an account. And just like all you have, like all of the students, you have your accounts that start with A20, whatever your IDs are. And then for me, it's my first name. And for the other tutors, also it's their first name. So these are nothing but accounts, right? So we're considered users on the system. Now, as a Unix administrator, you should be able to, add a new account. Um, you should know how to add an account. You should know how to, let's say, delete an account that's existing, and maybe even create groups. Now, what are groups? Groups are nothing but, let's say, you can create certain, you can add, so basically you can create a group and add permissions to files, all of the required stuff to a group, and then add multiple users to this group. So what happens is you have one group and it has many users in it, and all of these users that are in a group have the same permission and access to the system or files, whatever that is. Okay, now why do you create groups? It's because it is easier to maintain and manage. Why? Because let's say you have a department, which is, let's say, IT department. So all the users in the IT department would need access to, let's say, the same software, the same whatever files, permission, and all of that. So what happens is that you can create a group and add people to that, and so the next time a new member joins the IT department, you can just add them to the group. You don't have to figure out what permissions or what files or what access you need to give to them. So that makes life easier for the administrator. Okay, sorry. So now now we're talking about adding, deleting, and all of that. So we'll take a look at that. Now here, let me scroll this so I have space to write. So we spoke briefly about users and about groups. Okay, so let's say you want to now add a user. Now, from here onwards, the commands that we're going to look at, you will not have permission to use them. So you need to just know them, understand how they work, and that's about it. You don't have to practice them. Okay. So if, let's say, you were going to add a user, you would use the command user add. Okay, that's the command for adding a user. That means you would write the command user add and then the name of their account. We'll look into detail how it's done, but the command is user add. So that's for the user. Now, if you were going to add a group, you would write group add. Okay, simple. The only thing that's different is user and group. The command is the same. It's actually one word. Okay. Then you have delete. Let's say you want to delete a user, you would write the command user del. Okay, user del will delete the user. If you want to delete a group, you would write group del, which will delete the group. So the next thing is, let's say you want to modify. You want to modify the account, some settings, some access. So how would you do that? You would use user mod. Okay, notice how it's always taking the first three words. That's one way to remember for remembering it. User mod and then group mod. And then one last one is, let's say you want to change or set password. So change or set password. We've used the user command for this. It's pass wd. And then for the groups, it's G pass WD. So G is here representing group. Now, all of this, don't worry about it. All of this information is there in the slides. I just don't want to go through slides because then to me, it would feel like I'm just reading through the slides and I don't know if it's making any sense. So I'm trying this approach, but anyway, all of this information is available in the slides. You can go through that at any time. Okay, so let's say I want to create a new user. How to use the command? It would be user add, and let's say I want to name the user Kevin. Okay, for you, your user accounts were created using user add, capital A, your student IDs. Okay, so that's a good thing to know. You can even add flags to, or what we call arguments or options, to the user add command. So let's say you okay, sorry. So let's say you want to create I want to create the user Kevin, but with different options. So let's say I would write it this way: user add minus C. This is Kevin IT, and then minus M minus S slash bin slash bash Kevin. Okay, so let's look at this in detail. When you put dash C, it basically adds a comment, or I would even call it like a note that this account is for Kevin from IT. Just a reminder, it's optional. You don't have to add it, but it's like a note for you to remember, okay, if there are 10,000 Kevins in a company, which person is this for? Maybe something like that. The minus M here, this basically automatically creates the home directory for the user with the same name. So under the home directory, if you remember, the first directory is slash, right? And after that, you have one directory, which is home. And under home, you have all user accounts. So dash M will actually create a folder, Kevin, under the home directory. So this particular option creates this folder automatically. Now, dash S basically assigns the shell for the user. So how are they going to log in, the way they're going to access the system, that is represented here. So uh, dash S, too many things to remember. Dash S and then bin bash would mean that the shell, this is basically shell, is bin bash, and then this is just the name of the account. Okay, again, they're optional, but it's worth remembering them. Maybe there can be a question on that. So you just remember C stands for comment, M stands for automatically creating the home directory as the same name as the account here. And then dash S is for shell, which login shell they're going to have. Now, when you create a new user in the system, there are directories that are created for the user in the file system. We know that one directory is here. So under the home directory, one folder will be created. Just like all of you have a folder under home with your student ID, similarly for a new user, they will have a folder under home with their account name. Okay, that's one folder. The other folder is basic. So let me write it again here. So when you create, or when new user is created, directories are added in. The first one was slash home, and then whatever the user is, and then slash var slash spool slash mail, and whatever the user account name was. So the dash is for the user account name. Now, just remember this. One is in the home directory, and then the other one is in the var spool mail directory. Now, the second thing we looked at was user del, which is to delete a user, right? So if you want to delete a user, let's say the account that I created for Kevin, I want to delete it. So I would write it as user del space and then the name of the account, Kevin. Okay, that will delete the account with this name. And then there are other flags that you can add. So you can even write it this way: user del minus fr Kevin. What does this stand for? So minus f basically stands for force, which means even if Kevin was logged in, the account will still be deleted. Okay, it doesn't matter if he's logged in or not, the account will be deleted by force. Minus r basically stands for recursion, I think. Oh, not recursion, sorry, removal. So you remember the file, the directories that are created when you create the user accounts? If you add -r, those directories will be deleted. Created directories for user will be deleted. Okay, so -f for force, -r for the directories that were created for the user when their account was created, those directories will be deleted. Okay, when you run just user del Kevin, those directories are not deleted, they will still be there. So that's a flaw. And as a system administrator, you need to be aware of these things. And we'll discuss about this later on as well. Again, for all of these commands, just remember you can always use the man command for help so that you can go through the manual. And in your exam, there may be, so basically all the commands that we're going through will be there in the exam, right? But maybe you have to figure out something new about a command. So you should know how to use the manual. I recommend that for each and every command that we're learning, you practice how to use the manual. It will be very helpful for you in the exam as well. So I would now recommend that you, for the group add and for the group delete, you use the manual here to see how it works. Basically, it's very similar to user delete, but just figure out how they work using the manual. Okay? Now, let's say this Kevin user that we have magically created, let's say they were working in a company that you were hired in, and when you were hired, they were retired, let's assume. They got retired and so they left the company. Now you need to make sure that all their accounts, all their access, everything from the system should be deleted. So they can't access back and nobody can access their files, right? So how would you do that? Your first option would be, like I said, user delete and then Kevin, right? But that doesn't delete, like I said, their folders or their directories from the home folder and from the var school mail folder, right? So for those, for Kevin, his folders will still be there. Now, it's not an issue, maybe as much because the account is deleted, so the person cannot log back in. But the issue occurs when let's say another person joins the company, they have the same name as Kevin, and you assign them using, let's say, um, user add Kevin. You assign them the same name, the same account name. Now, for this account name, there's already a folder that was not deleted from the home directory and from the var spool mail directory. So it's um, it's weird that this new person will have access to all the files under these two folders that the old Kevin had, right? So that's where, like I mentioned before, that's where it is necessary for you to use -fr so that these folders and files are also deleted, and any new person that may have the same ID as the old account does not have access to any of the previous data or information. All right, now does that mean that using -f, oh, you don't have to use -f because it stands for force, but you can just use -r in this case as well. So anyway, now -r doesn't guarantee removing all files. It removes these two here, but then you have to also go and look manually for files that may have been created by this user that are elsewhere, and then you have to remove those manually. But the major security risk is that these two folders should be deleted, because if any other new account is created with the same name, the new person will have access to everything the old accounts had, the old folders had. Okay. Now, there's a way to, now, so far we've discussed manage users. Manage is nothing but add, delete, update, etc. Um, we've discussed managing users, right? Now, all of this was through basically CLI, which is you write commands, but there's also a way to do it through GUI. Okay, and that's basically through editors, like, not editors, through um, softwares that are called GNOME, KDE, and Unity. And these allow you to do the same things but with a graphical user interface. So if I can show it to you here, maybe in the PowerPoint. Yeah. So if you take a look here, this is a graphical method of adding users or managing users. So you could click on this button here, add user, and then fill in the details, and the users that are added will be shown here in this section. You can add a group, you can delete a user, so on and so forth. But this is through clicks and, buttons and clicks. Then here, again, group users, you can select a group and then add users to that particular group as well. That can happen as well. Again, this is GUI, GUI, but CLI is more like to automate things. Maybe you can write one line of code, one command, add it to a script, and make it run multiple times. So it can create bulk accounts or large accounts. But with GUI, you have to go one by one, and you have to add accounts or use groups one by one, and that's for people that maybe don't know a lot about administration of a system. Okay, then, okay, so coming back to our beautiful slide here. Now this is important. There are some special files um, on your system. The first one is the directory itself that has the special files. It's called the etc. Okay, what this directory contains is basically configuration files, config files, for basically all the programs that are running on the system. So you have the configuration files for programs on the system. Okay, there's another important file within this directory, which is etc/pass.wd. This is S. I apologize for my handwriting, but this file contains list of users. This is important for exam, this one. Okay, it's very important. So etc/passwd, list of users, it contains the list of users. So for example, if you go and log into a system, to the Unix system, what happens is the system goes and checks this file to see whether the user is basically existing or not. Okay, so it contains all the information about all the users on the system. And it has, let me actually show it to you. You need to remember this structure. Okay, here. So how do I do this? Anyway, I'll just do full screen. Okay, so what are the contents? The first one here, let me use the laser. So this part here is basically your username, your ID with a capital A. We all know that. This is a placeholder for encrypted password. So the password, the encrypted password used to be here, but it's no longer. And we'll look at that in the upcoming slides. But this is the placeholder, meaning it's an empty space, but it used to be for the encrypted password. Then you have UID, which is your user ID, your group ID, the group you belong to. Then there is a user description. So it's like the comment, the -c that was there in user add, that would be used here if there was something written with -c. And then your home directory. So here /home/your account is basically your home directory, and this is your login shell. So /bin/bash. So when you log in, you can log in through this, basically. So all of this is present under etc passwd. You have to learn about the structure. There can be a question based on, okay, what's the first column in this file? What's the fifth column in this file? And you have to figure it out. So that's passwd. Now, I told you that there is an encrypted password placeholder here. Previously, there used to be the encrypted password here, but then they figured out that maybe it's a flaw in the system to have it here, and therefore the password was then moved to something called, to a file called /etc shadow. So that's what I just said. That's what I just said. The file etc shadow is not word readable. So if you open it, you will not know what it means, what is there. You will not know anything. So that's a way of protecting the passwords. So list of users is /etc/password, passwd. It's very important for exam. Okay. Then there is /etc/shadow, and that's encrypted password, not word readable. Okay. Um, Now there are other files like etc group, and then etc g shadow. So for the group, it's basically the names and the list of users. So group names and group users. And for this one, it contains encrypted group passwords. So for this one, it's for the user accounts, and for this one, it's for group encrypted passwords. Encrypted group passwords. But this one, I mean, they're rarely used, not that often. But the shadow is often used because every account has a password, right? So now each of these files that we just spoke about, the 4 special files, passwd, shadow, group, and then gshadow, each of them, you can edit them using, what's it called? VI. But you have to use a special version of VI. So here, if you take a look, it says the password file or passwd file can be edited using VIPW. The shadow will use the same command, but at the end you will write -s, and then group will be VIGR, And then for group shadow, you will use the same VIGR but with dash S. So that's basically how you would edit all the special files in the etc directory. So we've looked at the way you can edit those files. The next thing is, how can you see the list of all the users that are currently logged in on the system? Now, I think it's better if I show this. So let's log in. Okay, I don't know if this will be readable in the video, so let's quickly change the size of the text. Okay, so here when I type W, just W, it shows me all the users that are currently logged in on the system and what they're doing. Okay, so basically you can see what they're doing, what was their login time, where they logged in from, all of those things. So basically the whole information. I just used the W command, right? So that showed up. So it basically, the command W will show you all the users that are logged in and what they're doing. There's another command, which is who. So if you use who, it just shows you all the users on that are logged in on the system and maybe their time that they logged in, the time of login basically, along with the place, but it doesn't show what they're doing. If you want to see what the user is doing, the users that are logged in, then you will use the W command. If you want to just see the user that are logged in, along with all the details like their login time, their location, like where they're logging in from, then you would use who. There's one more, which is users. Actually, yeah, users. And for users, it's just showing as just names, as in just the users that are logged in. All of them are showing the same thing, but with W, you can see what the user is doing. With who, you can see who is logged in along with their information like login time and the location, as in the IP address. And then for users, it's just a list. So that's like the three ways that you can log in. Why can this be useful for the system administrator? They can see what the people are doing on the server, or who is logged in, and it's I think it's secure maybe to see who's logged in. So yeah, and if you can come up with more reasons why this can be useful, then we can discuss that in the class as well. So after this, we have another section basically that we will look at, and which is very important, by the way. So let's look at it. It's basically about the file types. If I can scroll here, Unix file types and permissions. So we will look at the different file types and the permissions that are associated with files. So when, I think it's best if I show it in, actually no need, I think let's just use presentation. Okay, so here when you do ls minus l, all right, so when you basically issue the command ls minus l, what you see is similar to what is shown here. The first thing is basically here, it's the file type. When it says D, this means it's directory. Okay, if it was just a dash, that would mean it's a file. Okay, so if it's D, it's a directory, otherwise it's file. We'll look at it in detail. The next set of characters represent permission, just like how it's shown here. So the first one is file type. The next set is permissions. File type and permissions are together. That's why probably we're going to learn about them together. I still don't know what this is. I will try to figure it out. Okay, so we looked at what the file type is, what the permissions are, then who owns it. This is basically the owner. Okay, the next two names will represent the owner of the file, and then after that you have the size of the file in bytes. So this number basically represents the size, which is here, and then you have the modification date, the last modified date, I would say timestamp, and then the name of the file. Okay, so timestamp and file name. So what is the type of the file? Then you have permissions, then you have owner, then you have size, then you have time and date, and then you have name. Okay, this happens, I mean, you can see all of this information when you issue the command ls-l. Permissions, okay. So Unix file types, all devices are considered a type of file. Just like how I mentioned previously, this one is a regular file. This is a directory. When it says D, it's a directory, which means it's a folder. Then L stands for symbolic link, P stands for named pipe, S stands for socket, CB stands for device name, and D stands for door, capital D. I think it's a good question for exam, so it would be best if you can remember what each letter represents. There could be a question in your multiple choice exam for the theory part, that what does S stand for what does the letter S stand for when you use ls-l. So okay, now there are three classes of permissions. You have one for the owner and the user, so that's your first one. Then you have group, and then you have others. It's basically, you can remember it as UGO. This is for the user, this is for the group, and this is for others. Now, how do you know, I mean, where can you see these groups, right? This one, like when you do ls-l and the first two, the first, I would say, bunch of characters, the first one we know is the file type. This whole is going to be the permission. Within that, you have three characters for each set. So this is considered 1, this is considered 2, and this is considered 3. Similarly here, this is considered 1, the dash is considered 2, and this is considered 3. And then you have the last one, 1, 2, 3. The first box basically represents the owner or the user. Okay. The second box here represents the group. Okay. And then the third represents others. Okay, now we will learn what each of these stand for, but you should remember the first three characters represents the user permissions. Then the next, I mean, the fourth, fifth, and sixth characters represent the group permission, and the 7, 8, and 9th characters or letters represent other permissions. Okay, now this is important. When now remember, for each of them, for UGO, we said there are three letters, right? So for U, you have 1, 2, 3, and for G, you have 1, 2, 3, and for O also you have 1, 2, 3, right? So if all the three characters, let's say in U, or let's say in others, let's use others as the example. Let's say in the others character, all of them are just dashes. So this is the first character, the second, and then the third. All of them are basically dashes. This means you don't have any permission, no permission at all. The next one, it says that you have the first one is dash, the second one is dash, and the third one is X. X represents execute permission. Okay? If you have, basically what they're trying to say, if there is any X in any one of them, usually they come in the same order. The first one will be R, the second one will be W, and the third one will be X. If you have X, that means you have execute permission. If you have W, that means you have write permission. Okay, and if you have R, that means you have read permission. Okay, so like I said, if there is R, it's for read, W is for write, X is for execute. If you only have X, that means, I mean, if you have X in any of them, you have execute permission. If you have W, you have write permission. If you have WX, that means you have write permission and execute permission. If you have R, that means you have what's it called? Read permission. If you have read and if you have R and X, you have read and then execute, read and write, and then read, write, execute. This means you have all the permissions. Okay. Now, for each of these permissions, you have numbers associated to them. If all of them are dashes, that means it is 0. Okay. Now here, execute is at the end, right? For execute, the number is 1. Okay. And for write, the number is 2. Just remember this. 0 means all of them are dashes. 1 means you have X at the end. And then 2 means you have W in the middle. For 3, it's basically, if you add these two numbers here, you will get 3, right? So 3 will be W, X, and then dash. Okay. Now 4, it can be, 4 is basically R. Okay. Just remember this. 4 is R. So now 5 can be 4 plus 1, right? So that means 4 is R dash and 1 is X. Then you have 6, which can be 4 and then 2, right? So 4 is what? R, and 2 is W. So at the end there will be dash. And then 7 is basically 4, 2, and then 1. So here 4, 2, and then 1 will make it R, W, X. You can just remember the numbers, or I think it's best to remember the numbers and the symbols together. So after this, what does the execute permission for a folder mean? It means that you can, if you have execute permission, you can cd into it. If you don't have execute permission, you cannot change directory to that folder. And when is the execute permission file useful for a file? When you want to basically run a script. Okay. So after that, we have learned how to create files. We have learned how to copy, move files, and all of that. Now we have to. Now we need to learn how to modify permissions on a file. Okay. Now, for modify, for modifying permissions on a file, you have the, what's it called? The command chmod. Okay, chmod stands for modifying permissions. Now, the next part of this command, it's the ugo. So you need to put the, we'll look at what we need to write here, but you need to put the permissions for the user group, the user, the group, and then others, and then whatever file or directory name it is. Here, you can, for example, if you write chmod 7, which means everything, right? For the user, they can have read, write, and execute. But for the group, it's only read, and for others also, it's only read. Why? Because we know the number 4 here stands for read permission. So that's what is going to happen. The owner or the user will have all the permissions, but the group and the others will have only read permission. So read only access for all, and except the owner who has all permissions. Now, you need to know all all the different ways of modifying permissions, because we don't know which kind of question can show up. This is a very, very, very important topic, which is why I am also recording a video so you have access to it even after class. So basically, the first syntax that I showed you is you can represent using the numbers. So you can write chmod 744 and your file. That was the first way. The second way is using these symbols. Okay. chmod is already there. There's a new thing here, we'll talk about that, and then the file name is already there. So the only thing that's different is this part, the second part, right? In the second part, C here stands for the class of users. So UGO, it can either be, so instead of C, you can either write U, G, or O, anyone, okay? Plus or minus is either, so basically when you write plus, okay, how do I explain this? If you write plus, it means enable, it means give permission, okay? But if you write minus, it means take away permission, okay? I hope that makes it clear. So enable or disable is basically like giving permission with a plus sign or taking it away with a minus sign. And then P is basically the type of permission, which is RWX, read, write, or execute. Now let's look at an example. You have chmod, which is basically the command for changing permission. U here stands for the owner or the user. Plus means give the owner write and execute permission. So this is write and execute permission on my file.txt. So adds write and execute access for the owner. Now, on the second example, you can see chmod, we're saying for the group, for the group, oh my god, for the group, this means remove read permission. R is for read, right? Then comma for the next group, basically, for the next set of permissions. We're saying for others here, for O means others. For others, also remove the write permission. Okay, and then on this file. So remove read access for the group and write access for others. Okay, so basically you either represent in the first letter will either be U, G, or O followed by plus or minus for give or take, and then your permission, whether that's read, write, or execute. And then if you want to write it for different groups, you can put a comma. So let's say you can write for U here, whatever their permission is. You can write for G here, whatever their permission is, and then you can write for others here, whatever their permission is. This is important. The amount of time I'm spending on this, I know it's a lot, but this is important. These are the kind of questions that will show up in the exam. Now here, okay, let's try to do this. I think that will make more sense. So let's go to putty. Okay, so here, so I need to first of all, change the font size. Okay, so here first I should create a file called mystuff.txt, touch mystuff.txt. So done with that. Now you have to change the permission for each of the files. So here you need to use the octal codes. Octal codes are the numbers from 0 to 7 that we saw here somewhere. Yeah, so the numbers from 0 to 7, they represent the octal code for the permissions. So here, where is it? Okay. No, wait. Okay, here, yeah. So you need to set the permission using octal code, and for the user, they will have full permission. So that is 7, right? All permissions are 7. So Chmod 7 for the user. The group has only read permission. We know read is 4, the number 4, right? So 4, and then other has no permission, which was 0. So 740, and then the name of the file is mystuff.txt. Okay, now if you do ls minus al, oh my god. Okay, let's do ls minus l. It's the same thing. Anyway, where's my stuff? Okay, here. So if you can notice, it's a file. That's why there is a dash. Then there is the first 3 for the user or the owner, which was all permissions. For the second one, we only gave read permission. That's why we wrote 4. And for the last one, we gave no permission. That's why everything is just dashes. All right. Now, what else? Now, sorry, create a file. Let me clear this. It's bugging me. Okay. Create a file mystuff2.txt, and using the symbolic operator, set the same permissions. So touch mystuff2, okay, and then using the symbolic. So chmod, symbolic is what I just showed you. The previous one. This is symbolic. So if the question says use symbolic operators, this is what you need to use. If the question says octal, you need to use the numbers. So here, for the user, we're writing for the user first, right? For the user, give the user all the permissions. So read, write, execute. You have to write it in that order, okay? Comma, for the group, it should be what? Give, read, and then for others, remove the read, write, execute, and then mystuff2.txt. ls minus l. We made a mistake here. It should have been just read for the group. So you can change that by writing chmod g minus w. So remove write permission from group for my stuff to txt. Now if we do ls minus l, it should have the correct permissions. Okay, now there's another way of doing this. So let's say I want to change permissions. You can just, for the same one, for the same file, but I want to give, let's say, read and write for everybody. Okay, for the user, for the owner, I want to give full permissions, but for group and for others, I want to give just read and write. So I can write it this way: chmod for the user equal to, it should be write, read, write, execute, comma, for the group it should be read and write, and for others it should be, let's say for others I want to leave it empty so that you can see the example for empty as well. So for others I don't want any permission, so I'll write it this way: o is equal to, and then nothing, and then the name of the file, mystuff2.txt, ls minus l. Now see, it has the same thing, read write, but empty for others, for the others. All right, so that is done. Same format as file permissions. The same permissions apply for directory as well. When you have read permission on a directory, you can basically, let me open this. When you have read permission on a directory, you can list the files in the directory. So you can do ls. When you have write permission, you can create, delete, or rename a file. But when you have execute permission, you can cd to the directory. If you don't have execute permission on a folder, you cannot cd into a directory. Okay, and to get the information also about the files in the directory, apart from their name, like if there is other details that you want to know, then also you need to have execute permission. So just remember this: read permission on a directory will allow you to list files. Write permission will allow you to create, delete, and rename, and execute permission will allow you to basically search, so cd or look for information. So for files, again, the same thing happens. If you have read permission on a file, you can read the file. If you have write permission, you can modify the file. You can create and all of that. And if you have execute permission, that means it's basically a script and you can run that script. Okay, and then the next one, examples of directory permissions. The execute bit allows examination of the file. So the first one is basically directory. You have read and write for each of the groups. So you only have read, and write is also there, but you don't have any execute permission on a particular directory, let's say. When you do ls, it will list the files in the directory, but no other information will be provided. Like if you do ls minus l, you cannot see all of these information, because why? Because you don't have execute permission on the directory. If you have execute permission on the directory, then you can see all the details, like the permission, the time, the modification time, the owner, the size, all of that. But if you don't have execute permission, you are not able to see it. Okay, and then what else? What else? What else? Okay, I think that's it for. I think we will leave it at this point, and the remaining slides we will go through it in class, because I want you all to understand the concept better. So if you have questions, we can ask those. I mean, you can ask those questions, and then we can work on the lab. Okay. So I think this is it for now. And yeah, we'll continue in the lab class. All right. Thank you for watching.